Okay, so welcome to learning intention number 9, aim number 9, lesson number 9, however you want to call it. Okay, so it says how many quarters, nickels, and pennies are needed to make $1.13. So basically we have different answers for that. Okay, so one of the answers could be I don't know, 4 quarters. I guess 4 quarters make $1, right? So 4 quarters. You could write 4 quarters. I'm not gonna write 4 quarters. Okay, 4 quarters. 2 nickels. How do you spell nickels? Oh. I'm not gonna put the dog in the video.
Why?
Because no. I'm gonna stop being on the video because every time I'm on the video he comes and bites the cables and all that stuff. No. And 3 pennies. Yep, that's $1.13. Nice, right? Okay. So B, it says fill in the blanks. So 8,943 is equal to, well, 8 times 1,000 is 8,000. 900. 4 times 10 is 40. And then 3 times 1 is 3. So that. Okay. Now what else? Oh wow. Now it's in exponent form, in exponential form. Okay, no problem. 8 times 10 to the 3 is 10 times 10 times 10, which is 1,000. So it should be 8 times 1,000. 10 to the second is 100, so still 9, 10, and then 3. Wow, that was difficult, right? Sure. Okay, let's go to C. What do I have for C? The same number, but now I have 20 to the third power. 20 to the third power is 20 times 20 times 20. Okay, so what is 20 to the third power? Let me see. 20 to the third power. That's 8,000. Okay. Wait, no. 20 to the third power is 8,000. So this number should be 1. 1 times 8,000 is 8,000. Then 20 to the second power is 400. So I would need 2, yeah. 2 times 400 is 800, and then here times 20. Okay, do me a favor, you need to pause this and figure this out yourselves. Seven times 20 is 140, and then 3 times 1. Okay, but you need to figure out on your own. This is like 4th grade stuff, so I don't want to be doing it for you. Okay, fill in the blanks. 113 should be what? What number goes here? Oh my god. Oh wow, thank you. What number goes here? And what number goes here? Beautiful, beautiful, beautiful. Okay, exercise number 2. Let me see if I can zoom out and hopefully everybody can see it at the same time. Oh gosh, let me see. Okay, so I don't want to make it smaller because then it's gonna be like, cannot see, Mr. Becker. Alright, now let's be as general as possible by not identifying which base we are in. Just call it base x. Okay, so we have an expression. This is what we call a polynomial. Okay, it's basically an expression that involves variables, exponents, okay, and regular numbers. So we have the expression x to the third power plus 2 times x to the second power plus 7 times x, which you could say 7x plus 3 times 1, or equivalently x to the third, okay, plus 2x squared, okay, plus 7x, which is 7 times x, plus 3, which is 3 times 1. Okay, what is the value of this expression if x is 10? Well, if x is 10, if I was to rewrite the whole expression, I would write x to the third power. If x is 10, it will be 10 to the third power, plus 2 times x to the second power, that would be 10 to the second power, okay, plus 7 times x, so just x, okay, plus 3 times 1, which is 3. Okay, now we put that in the calculator and we get, what do we get? That, right? But you have to do it yourself first. Don't wait for me to do it, okay? I'm just trying to help you here. I'm just trying to, like, once you do it, you compare your answer to mine and then you see, oh wow, I messed up or I got the wrong answer. All right. So it says, what would happen if x is equal to 20? Okay, so you follow the same process. So I'm gonna give you time to answer the question. So you have x to the third power, 2x squared. So you will have 2 times x squared. Okay. And then 7x. And then 7x plus 3. Alright. So what is that equal to? Come on, use the calculators. Okay, very good. 8,943. Okay, now what does it say on D? It says when writing numbers in base 10, we only allow coefficients of 0 through 9. Why is that? I don't know. When writing numbers in base 10, we only allow coefficients of 0 through 9. Why is that? Well, once you get 10 of a given unit, okay, once you get 10 of a given unit, right? Once you get 10 of the given unit, you also have 1 of the unit to the left of that. So you also have 1 of, oops, sorry, let me see. 1 of, you also have 1 of the given unit to the left of that. As simple as that. Okay, let's answer the next question then. Okay, good. So what is the value of 22x plus 3 when x is 5? How much money is 22 nickels and 3 pennies? Hello? You gotta do that one. So you have 22x, but what is x? X is 5. Okay, and then plus 3. Now 5. Wait, hold on a second. 5 can be represented as nickels. Okay, cool then. So when you multiply that, you get 113, which is equivalent to $1.13. Okay, $1.13. Let's go to C. Okay, what number is represented by 4x squared plus 17x? Oh my god, who texted me? Oh, okay, that's Miss Sweeney. Okay, What number is represented by 4x squared plus 17x plus 2 if x is 10? Oh, please. Remember what x is. So this is 4 times x squared. So 4 times 10 squared plus 17x. 17 times x, which x is 10. So it's 17 times 10 plus 2. And that equals to... Cool then. Alright, so we got that one. Okay, let's go to D then. What number is represented by 4x squared plus 17x plus 2 if x is negative 2? Or if x is 2/3. So that means that we have to do both. So remember, 4x squared means 4 times x squared. What is the value of x? Negative 2. So 4 times negative 2 squared plus 17 times negative 2 plus 2. So that is the first scenario. So what do I get? Right, we get negative 16. All you have to do is put it on the calculator and you'll get it. Now, why am I showing you this one when I was supposed to show you this one? So once again, I'm gonna have to repeat it. So what number is represented by 4x squared plus 17x plus 2 if x is negative 2? So we get this negative 2 in lieu of x. Instead of x, we write negative 2. So 4 times x squared will be negative 2 squared plus 17 times x, in this case 17 times negative 2 plus 2, that's negative 16. Now let's try when x is negative, when x is 2/3. So we get 4 times 2/3, okay, squared plus 17 times 2/3 plus 2. Alright, so I'm gonna actually go the extra step and I'm gonna say, okay, 4 times 2/3 squared. 4 times, what is 2/3 to the second power? Well, when you raise a fraction to whatever exponent, you're raising the whole thing. So that's 4 over 9, because 2 squared is 4 and 3 squared is 9, plus 17 times 2/3. When you multiply by a fraction, when you multiply a whole number by a fraction, it's nice if you want to put the 1 under the number, or if not, just remember that this you multiply by the numerator and you get divided by the denominator. So 17 times 2. What is 17 times 2? Let me see. Oh my God, come on, my math skills. 34. So 17 times 2 is 34 over 3. If you put a 1 under the 17 times 2 is 34, and 1 times 3 is 3, so that's how you get it. And then plus 2. Now, 4 times 4 over 9, that's gonna give you 16 over 9. And then the rest is 34 over 3 plus 2. If you wanna put it over 1, that's fine. And now, remember something, you need to find a common denominator. In this case, where does 9, 3, and 1 meet on the times table? At 9, right? So my common denominator is gonna be 9. Now you gotta turn this into equivalent fractions. How do I turn this into a 9? Multiply by 3 over 3. How do I turn this into a 9? Multiply by 9 over 9. And then, once you have them equal in denominator, you add the numerators and subtract the denominators. And that's what you're gonna get, but you have to show more work than I did. What number is represented by negative 3x squared plus radical 2? And look, the x, I don't think the x is included here. That's why when I do it, I like to close in the whole radical thing. Okay. So when x is radical 2. So how do I do it? Well, let's see. Negative 3 times radical 2 squared plus radical 2 times x, which is radical 2, plus 1/2. All right. So let's see what this says. When you have, remember that squaring a number is the inverse of taking the square root. So when you apply both like that, then they're gonna cancel each other. So this is gonna cancel with the square root. So basically what you have here is negative 3 times 2. I hope you understand that. Squaring a number and taking the square root are inverses. One is the inverse of the other. So you have to, they cancel out. So if you have the square root of 2 to the second power, they cancel out. Therefore, only the number gets liberated right here. It gets freed. So I'm free. 2 is free. So that's why you have negative 3 times 2. Plus, now when you are multiplying radical 2 times radical 2, when you multiply a square root times itself, is the same thing as squaring it, right? So this is the same thing as saying radical 2 to the second power. Or if you want to, you could say that radical 2 times radical 2 is radical 4. Although it's more advisable to say that radical 2 times radical 2 is radical 2 to the second power, so they can cancel each other. So what you have, negative 6. This radical 4 is 2. Negative 6 plus 2 is negative 4. Negative 4 plus 0.5, okay, negative 4, so you have negative 4 plus 1/2. So then, this is negative 4 over 1. In order to add them, we need to have the same denominator, so we need this 1 to become a 2. So we have to multiply by 2. So we multiply by 2 over 2. So we end up with negative 8 over 2, right? When you multiply it by 2 over 2, plus 1 over 2. And then we end up with negative 7 over 2. And that's it, and that's your answer. Oh, okay, let's move on then. Oh, okay, so a polynomial expression is either a numerical expression or a variable symbol, or the result of placing two previously generated polynomial expressions into the blank of the addition operator, plus, or the multiplication operator, plus. Kobe, no, Kobito, go over there. Váyase para allá. Lo voy. Ay, Kobe, ten tu juguete. Alright, so just a little technical support. Just, you know, the dog is kind of like acting out, and it's you know, it's about this time where he gets activated, and then I have to like grow gray hair. It don't matter. Oh wait, hold on a second. I caught you again. Alright, so find each sum or difference by combining the parts that are alike. So this is your job. Take your time, do it. If you did it before I did, then congratulations. Remember to give you extra points. If you didn't, then too bad. Alright, so we're gonna start. Remember that when you add polynomials or subtract polynomials, you gotta add the like terms. Okay? So what is this equal to? Well, let's see. 4x squared plus 2x squared is 6x squared. Good. So look, what I do is I'm gonna cancel them out to know that I worked them out already. X goes with 1. No, goes with 3x. So 1x, it doesn't have to have the 1. How many x's do you see? 1, duh. So then that's 1x. So 1 plus 3x is 4x. And then 7 is a loose number, just a regular number. And 1 is also a loose number, regular number. So 7 plus 1, 8. Got it? Okay then, so let's work the other problems out. Yeah, I can make this larger. Okay, let's do it. Three x to the third minus x to the third is 2x to the third. Negative x squared minus 5x squared. What is negative x squared? Negative 1. Look, they're like terms, so you don't have to worry about the x and the exponent. We have to worry about the coefficient. So this is negative 1 minus positive 5. Look, negative 1. Where can I write it? We have negative 1 minus positive 5. In other words, we have negative 1. Remember that what I said? Just multiply the symbols together and you get one sign. So we get negative 1 minus 5. Go to negative 1 and then move 5 units to the left and you get what? Negative 6, right? So this is negative 6x squared. Now we have 8 minus, we got x to the third, we got x squared. 4x goes with nothing. 4x goes with nothing. But remember something. You have a subtraction sign here. And subtraction is also distributive. Remember how I read it. Remember how we read it. Negative 1 minus 5. Negative 1 minus 5. But then again, we have a 4x, but we have a minus sign here. So the minus multiplies the 4x. So negative times positive is negative. So we have minus 4x, right? And then we have 8 minus negative 7. 8 minus negative 7. That's what we have. Okay, 8 minus negative 7. Look, 8 minus negative 7. What happens? What have I told you when you have two signs together? To multiply them. Negative times negative is positive. So therefore, in other words, you have 8 plus 7. Get it? Please tell me you get it. So 8 minus 7 is the same thing as 8 plus 7 because you multiply these two signs together. So we got 8 plus 7 is 15. So we get it. All right. Kobe, leave me alone. All right. So the next one. In the next one, we have to actually apply the distributive property first, and then we could like mess around with it. So let's utilize the distributive property here. So 3 times x to the third is 3x to the third plus 8. No. 3 times 8 is 24. Oh my God, that's making me say the same mistake. So I multiply by everything? Yes. Now, negative 2 times x to the third is minus 2x to the third. Negative 2 times 12 is negative 24. Now we're talking. Now let's add the like terms. Where are the like terms? Here and here. So what is 3x squared minus 2x? Sorry. What is 3x to the third minus 2x to the third? That's 1x to the third. Kobe, don't eat the phone. No. Kobe. Jesus. Oh my God. You wanna be on camera, Kobe? Cause you're killing me. So now what I'm gonna do is I'm gonna cancel this out. Kobe. Okay. And then let me see. 24x doesn't go with anything. You see 24, negative 24. Do not even think about combining them. This has an x, this doesn't, so you cannot. Please try to understand that. So I'm just gonna write plus 24x and then minus 24x. Gucci? Okay. Let us move on. Okay, here this is an addition, not a multiplication. So first, do I have like terms here? No. Do I have like terms here? No. So that means that I gotta combine this parenthesis with this parenthesis. So let's see. 5. I'm gonna write down 5 because I don't see any other regular number here. Now negative t is gonna go with 9t. So what is negative 1t plus 9t? Well, negative 1 plus 9 is 8. Negative 1t plus 9t is the same thing as saying 9t minus 1t is 8t. Now we're going with negative t squared. Negative t squared plus positive t squared. Nothing. Remember the additive inverses. Look, positive t squared, negative t squared, and you're adding, so they cancel each other out. Got it? Okay. And let's do this one now. Now you are going to do it on your own. I'm just gonna help you in a little while. So you see, the negative, since you have a negative, this is like saying negative 1 times p plus 2. So negative 1 times p is negative p. Negative 1 times 2 is negative 2. I hope you do understand this part. If not, then I'm going to have to explain to you until you understand it. Alright, so now do we have like terms? Yeah, we have 3p and positive 6p. That's 9p. So look, just in case, because I don't want to recount them again. 1, positive 1, right? 1 minus 48 is negative 47 minus p minus 2. Guess what? I'm not going to say I made a mistake because I'm the master here. But really, I still have like terms with the p. I forgot about this. So I'm going to correct my mistake right here. 9p minus 1p is 8p. So boom, boom. And negative 47 minus 2 is negative 49. Boom. Got it, right? Okay. So now, let us move on. Oh gosh, I gotta make this smaller so we can actually see what it says. Me muero. Okay, so Selena says that each of the following expressions is actually a binomial in disguise. So I'm assuming that's what they want us to prove. Alright, so that's not a problem. So we got each of this. So what am I supposed to do? For example, she sees that the expression in the first one is algebraically equivalent to 11abc. Okay. Oh, okay. She's happy to write this as 11abc plus negative 2a squared if you prefer. Is she right about the remaining 4 expressions? Well, let's see.